Hello, welcome back. I'm Mike with 184 Aerospace. Today we're going to be reviewing the fin can build for my level 3 rocket. It's going to be long, might be a little boring, but I hope that you're inspired and can use some of these concepts to build your own builds. Be sure to like and subscribe to YouTube, and also check out my Patreon. I've left a link in the comments. We're going to cover some safety aspects here. We're working with fiberglass and epoxy. You should always be wearing a respirator whenever you're sanding, drilling, cutting. If you want to, if you don't wear glasses like me, wear some goggles. I recommend the goggles if you're cutting or drilling. Wear some latex or vinyl or nitrile gloves. It's always a good thing to have. Just remember that inherently this is unsafe what we're doing. We're building big rockets. We're doing a lot of unsafe stuff. So just be safe and mind what you're doing. Don't do everything I do in this video. I will warn you about that ahead of time, and I'll let you know when there's practices that I've completed that you should not do that way. We'll review some of the chemicals we're using today for this build and assembly. We use denatured alcohol. I like to put it into a little squirt bottle. Always be sure to label your bottles whenever you transfer liquids. Acetone, we use this to prep the fiberglass for bonding. I use 5-minute epoxy. This is JB Weld Clear Weld. I don't really have a preference for epoxies when it comes to 5-minute. We are only using this for temporary bonding of structures while we prep for the heavy epoxy. This is 610. This is what we use throughout the fillet process in the video to come. Also, I use blue Loctite for any fastening locking that I need to do. So we need a jig to assemble the fins onto the motor mount tube. I originally made this foam board from a design from payloadbay.com. Their links are in the description. Basically, you go to the website, type in your dimensions. They give you a full-size sheet to print out and then cut out and put on this foam board. Now this foam board didn't work. It's pretty floppy. Remember, this rocket is ginormous. So we built a jig out of wood. And that's where we're going to continue on, 1/4-inch plywood.
So I remember how I told you not to do some of the things I do? Yeah, don't use this drill bit. Cut the hole out, put the motor mount tube in. We then printed out the Payload Bay template, glued that to the plywood, and cut that out with a skill saw. Test fit everything just to make sure it works. Everything's good. We super glued some speed squares onto it to reinforce the active fin we're going to be working on. Mix up some 5-minute epoxy here to put the fins on one at a time with the jig. We're just putting some epoxy on the root edge to tack it on. The first fin took the longest to align and get set up right, just because we didn't put the other fins in there, and held it in place for the 5 minutes so that it would be straight. The second fin went in pretty easily. Each one was easier than the last just because there's more fins in there holding itself against the jig. Sorry about the close-up of my elbow. And the third one went in without issue. Again, this was the easiest. This jig saved the day. I might suggest you cut it out of some thicker plywood, and that could make it a little more permanent, but more than likely this is going to go in the trash when I'm all done with the build. So not going to spend a lot of time on sanding. Everybody knows it's got to be done. I use 80 grit. I sand, I wipe down with alcohol, I wipe down with acetone, and then I wipe down with alcohol again. Epoxy the upper center ring on with 5-minute epoxy to hold it in place. We reinforce this upper fiberglass centering ring with a 1/4-inch birch centering ring epoxy to it. This is where the whole of the recovery system is going to be attached to, so we want it nice and strong. Tape this up to get a nice fillet, make it look cool, even though you will never see this again, hopefully, because it'll be inside the rocket once the rocket's fully assembled. Just wanted to make sure I didn't get any epoxy out where the outer fillets have to be set up and secured in. I could have taped up the motor tube, but I didn't. I'm going to use a 610 epoxy. First time, a little nervous. Let's see how it mixes up. We're going to try to do one side at a time until I get somewhat used to this epoxy. So I did 2 strokes. And we'll mix this together by hand. It came with a mixing nozzle, but because I want to try to use it, I haven't used it before, and I'm a little worried I might mess it up if I go all in. So you can just make sure it mixes really well so that I'm sure we've got what we need. You have to stay hydrated throughout as well. That is of top importance. So this 610 epoxy was nice and thick. It spreads well. It doesn't run. It didn't seem to sag on me. It was very cold out. I have a space heater running in the garage there. I will likely use the West Systems colloidal silica to make my own mix for the external fillets. That's basically what the 610 is, but it's kind of ready to go in a tube. It's also expensive. I still don't know how I feel about the mixing nozzle. That's kind of a one-time use thing, and you seem to lose a lot of epoxy in the nozzle itself. This stuff spreads well. It fills well. I like it. If you don't want to mix your own filler into epoxy, go ahead and buy this, I guess is what we could gather out of this. One thing to note, Most of these little mixing sticks or craft sticks do not always seem to be perfectly radiused on center. So if you're going to pull one way with them, pull that way throughout the whole thing. Don't roll it over and use the other side, because it actually shifts everything around. We waited about 30 to 45 minutes to peel the tape. There's some out there that say tape peeling footage is better than sanding footage. I'll let you guys be the judge of that. This is a custom printed ASA motor retainer. It actually goes over the motor tube as opposed to butting up to it. If you don't have a rawhide hammer, a rubber mallet should suffice. Again, I recommend wearing a respirator and gloves whenever you're drilling, cutting, or sanding fiberglass. This stuff's not fun on your skin, and you definitely don't want it in your lungs. We used 3 1/4-inch U-bolts in the upper centering ring, backed with nuts on the top side and a washer, and then backed with the washer plate that comes with the U-bolt, a lock washer, and a nut. All the mechanical connections are secured with Loctite glue. Then the motor retainer is held on with 12 8/32 screws, backed with nuts. Again, everything is locked together with blue Loctite.
Alright, so that gives us this assembly, this gigantic fin can. That's epoxied and reinforced down to the motor tube. We've got a solid motor retainer on there, and we've got recovery points. We're using 3 recovery points, and I got some inspiration from an Apogee newsletter article that I'll share the link in the description, and there's a graphic here that kind of explains that pretty simply. The next process is obviously to install this into the rocket fuselage. I do need to build a cradle for this rocket. It's getting big. Need something to structurally hold it while I'm working on it and while we prepare for flight. Thanks for watching. I hope you enjoyed this. I hope it's inspired you to go out and build your own rockets or some of the ideas I've used. If you got comments or concerns, leave them in the comments for me. Fly safe and aim high.